Assalamu alaikum. Today I would like to discuss about thyroid hormone synthesis. First of all, this is blood, this is thyroid follicle, and this is the lumen of the thyroid. In here, first iodide enters into the follicle. First of all, iodide enters into the follicle via sodium iodide symporter or sodium iodide co-transporter. Then this iodide, after entering into the follicle, it releases or it loses its electron, that means loss of electron. It loses its electron and becomes it loses its electron and becomes oxidized. This oxidized iodine, this is the first step, the oxidation. Then this oxidized iodine hooks up with the tyrosine and forms monoiodothyronine and diiodothyronine. This is a picture that this iodine enters into the follicle. The iodine enters into the follicle and then it loses its electron and forms and becomes oxidized. It loses its electron and becomes oxidized, and for this process oxidation you need an enzyme called thyroid peroxidase. And this oxidized iron hooks up with or binds with monoiodothyronine and diiodothyronine and becomes T3 and T4. And again in this step there is the same enzyme called thyroid peroxidase enzyme. And finally coupling happens, and coupling means monoiodothyronine and diiodothyronine becomes T3 and T4, and this is called coupling. In these three steps, that oxidation, organification and coupling, in these three steps you need only one enzyme. That's why this thyroid hormone synthesis is very easy, that thyroid peroxidase. Okay, then how can you block this step? This iodine is taken up by the follicular cell. If you give iodide, that means if you give iodide, then this uptake will stop, and by this way you can stop this pathway, that taking up of iodide, taking up this iodine by this follicular cell. And these three steps, oxidation, organification, coupling, there is only one enzyme, and these enzyme can be blocked by PTU and methimazole, propylthiouracil and methimazole. Now, after this thyroid hormone synthesis, you have to know that in iron there is T4, T3 and reverse T3. T4 by diiodothyronine and diiodothyronine forms T4, and monoiodothyronine and diiodothyronine forms T3. What is this reverse T3? Look at the position of the iron. Look at the position of the iodine. If iodine is if the position of the iodine is in this way, then it is T4. If the position is in the second benzene cycle, then it is T3, and if it is in the first benzene cycle, it is reverse T3. Why these active T3 and reverse T3? Because there are some organs which need more thyroid hormone and there are some organs which need less thyroid hormone. That's why some organs make active T3 and some organ makes reverse T3. And there is another thing you have to remember, that suppose you give a person thyroid drug, like you give that person T4, and you have to know that the half-life of this T4, the half-life of T4 is 6 days. On the other hand, the half-life of T3 is only 1 day. So if you give a person like levothyroxine, it will take at least a week to show some response, and you have to make that people aware that this thyroid drug has a half-life at about 6 days, and to show some response you need at least 6 days after giving the drug. And there are some unique things done by the thyroid, that there are some organs, that brain, gonad and uterus. Except these three, all the other cells biologically activity is determined by this thyroid hormone. Except these three things, three organs, that brain, gonad and uterus, all the other cells biological activity is determined by this thyroid hormone, that means thyroxine. And another thing you have to remember, that suppose you are in a room which has near about 40 degrees Celsius temperature or 60 degrees Celsius temperature, but in your body there is only 98.4 degree Fahrenheit. How your body adjusts this temperature? This adjustment actually is done by this thyroid hormone, thyroxine. Thyroxine actually does this adjustment. And another thing you have to remember, that there are two things, that is thyroglobulin and thyroid binding globulin. Thyroid binding globulin, this is thyroid binding globulin, this is transport protein. Though it is binding, this is transport protein. And thyroglobulin is just binding globulin, it just binds. Thyroglobulin actually binds in here, in this pathway. You can see that they actually binds with this monoiodothyronine and diiodothyronine and T3, T4. When iodine, after oxidation, when this organification happens, this thyroglobulin, there is some binding with this thyroglobulin. It's only just binds with the thyroid hormone, and the thyroglobulin is the storage form of thyroid. You can see here that after synthesis of thyroglobulin, this only binds with this iodine hooks up or binds with tyrosine and form monoiodotyrosine and diiodothyronine, and it becomes T3 and T4, and then it goes for storage in the vesicle. This is called colloid vesicle, and when our body need any thyroid hormone, lysosome comes, breaks this colloid vesicle and releases T3, T4 and export the particular organ. And there are some other thing, that as in the colloid we know that there is T3, T4, monoiodothyronine and diiodothyronine, and monoiodothyronine and diiodothyronine again goes to the cycle, and again it recycles. Okay, one question that suppose a person is taking propylthiouracil, which will decrease first? Thyroglobulin, thyroid binding globulin, T3, newly made T3. What should be the answer? It should be newly made T3. Newly made T3 will decrease first. And if somebody asks you that what intervention will help you to interrupt the greatest number of steps? Option A, surgery, beta blocker, propylthiouracil, high dose of iodine, radiation. It should be propylthiouracil. The question says that interrupting multiple steps, and the 3 steps is like oxidation, organification and coupling. We need only one enzyme, TPO, and this TPO is inhibited by propylthiouracil. That's why this is the answer. And another thing you have to remember that this thyroid binding globulin or thyroxine binding globulin actually binds with T3 or T4 in the blood, and bound T3 and T4 is inactive. That's why we always prefer free T3 T4 to diagnose a disease, because it is more accurate, because bound T3 T4 is inactive. And when this TBG, that thyroxine binding globulin increases, this thyroxine binding globulin increases in pregnancy, in OCP use, because if you use OCP there is increased estrogen and increased thyroid binding globulin, increased estrogen and increased thyroid binding globulin. So total T3 T4 will increase, and thyroxine binding globulin TBG is decreased in hepatic failure, in nephrotic syndrome, and in steroid use. Can you remember the function of thyroid hormone? There is a mnemonic 6B, that means brain maturation, bone growth, it is synergism with growth hormone, beta 1 adrenergic effect, that's why there is increased cardiac output, stroke volume and heart rate. And for this reason we are using beta blocker to stop those side effects. In case of hyperthyroidism, we actually prefer propranolol for this, and it increases BMR, basal metabolic rate, via increasing sodium potassium ATPase activity, It increases blood sugar, that means it causes hyperglycemia. In which pathway it causes hyperglycemia? By increasing gluconeogenesis and increasing glycogenolysis. And last function is it break down lipids. So it causes hyperglycemia. So there are 6b. If you remember this 6b, it will easy to remember the functions of the thyroid hormone as well as the regulation of thyroid hormone. And there is another thing, that Wolff-Chaikoff effect. What is this? Wolff-Chaikoff effect is if you excess iodine temporarily shuts off the thyroid hormone. That means TPO. If there is excess iodine, suppose you are living in a place where there is excess iodine, or you temporarily takes excess iodine, your body will shut down a TPO. So there is decreased T3 T4 production. So there is decreased T3 and T4 production. This is our protective autoregulatory effect, and this is known as Wolff-Chaikoff effect. And that's all for the thyroid hormone synthesis.